Today I shall discuss about the Vant Hoff equation in reversible reaction when the reaction attained in the equilibrium state by Le-Chatelier principle, and this is the Vant Hoff equation where log Kp is equal to minus del H is divided by 2.303 R into 1 by T, where del H is the change of enthalpy and 2.303 is the constant number to convert the ln into log, and R is the molar constant, and 1 by T is the temperature at absolute scale, that is at absolute scale temperature T, big T. In the case of endothermic reaction, when number of P is the X, that is log P, we may consider as Y, and mx, X is the 1 by T, that is the equation of straight line, where y by x equal to minus m, that is the tangent, that is equal to minus del H divided by 2.303 R, this is the tangent. When temperature of this reaction, that is in the case of endothermic reaction, when temperature increases, the rate of the reaction also increases. At the same time, log Kp must be increases, and in that case the graph, the tangent will be negative. And in the case of exothermic reaction, the reverse graph, so that here tangent is positive because here del H is negative, change of enthalpy is negative, that is in the case of exothermic reaction, so that y by x tangent is positive and the graph is reverse of endothermic. In this case, when temperature increases, the value of log Kp, that is the molar concentration in terms of partial pressure, also decreases, and the graph will be positive tangent. This is the exothermic reaction. In the case of exothermic reaction, where tangent positive, that is, if we put the value of del H, then it will be plus del H divided by 2.303 R, and the graph will be positive, and the Kp will be also decreases at the increase of temperature. In the case of exothermic and endothermic reaction, when temperature will be increases, then amount of product is also decreases, and the direction of the reaction will be backward, and in that time reactant will be also increases. In the case of temperature release in this reaction, then the product of this reaction will be increases, that is the rate of the reaction forward will be shifted towards reactant, and the reactant will be also decreases. And according to this equation, if we consider nitrogen when reacts with 3 moles of hydrogen gas, then it will be formed 2 mole of ammonia. In this reaction, this is the exothermic reaction where change of enthalpy is minus 92 kilojoule per mole. In this case, if we increase of temperature of this reaction, then amount of ammonia will be also decreases, and the reactant nitrogen gas and hydrogen gas also increases, and the reaction will be backward. If temperature will be decreases, then amount of ammonia is also increases, and the amount of nitrogen or hydrogen also decreases. This is the effect of temperature on exothermic and endothermic reaction. In the case of endothermic reaction, when nitrogen and oxygen reacts with nitric oxide, this is the endothermic reaction. Here 180 kilojoule per mole temperature will be required to happen of this reaction. In this case, if the temperature will be increases, the rate of the reaction will be forward. That is, the amount of nitric oxide also increases. At the same time, nitrogen and oxygen also decreases. If the temperature will be decreases, then the amount of nitrogen and nitric oxide will be also decreases, and the rate of the reaction will be backward. That is, the nitrogen and oxygen reactant will be increases. This is the application of endothermic reaction. Now we can calculate the Vant Hoff equation according to the Last principle. In the case of reversible reaction, when the reversible reaction attained in the equilibrium position, when the reaction attained in the equilibrium position, the factors temperature, pressure and concentration will be affect the equilibrium constant towards or forward, ultimately to decrease the aiding factor, that is the temperature and pressure in that cases. This is the Vant Hoff equation for reversible reaction in exothermic and endothermic reaction. And thanks for all.